So in today's lecture, we'll learn how to make plots in Python. There are many ways you can make plots in Python. There are many tools for making plots in Python, but there is one tool which is particularly popular, particularly widely used, and particularly powerful and versatile. And this library is called Matplotlib. Matplotlib. Okay. So the cool thing about Matplotlib is that it allows to make easy plots very easily. If you want to make very simple plots, it's very easy to make such plots. It's very easy to learn to make such plots. But at the same time, this library is very powerful. If you spend a little bit more time, you can make really sophisticated plots, really sophisticated, really high quality, publication quality plots. Nowadays, many people, actually many scientists, for example, prepare their plots in Matplotlib, myself included. So today, we'll go through the basics of Matplotlib. We'll learn how to make some basic plots today. Okay, that's the plan for today. All right, so let's start. So first, since I'm using a library called Matplotlib, I have to import Matplotlib. So let's import Matplotlib to my Python, to my Jupyter notebook. So I say import Matplotlib, and in Matplotlib is a big package, right? Big library. There is a module inside Matplotlib which is called pyplot, and most of the plotting capabilities are there. At least the ones which we are going to be using most of the time are in this module called pyplot. So I'm going to call that pyplot only. And I'm going to import it as PLT. This is a common way of doing that. Okay. So now if I run this one, okay, I made a mistake. It should be as PLT. Okay. Now Matplotlib is imported. I have it here. So since I'm using Jupyter, I have to do one more thing. I have to tell Jupyter that when I make a plot, I want that plot to appear on this page. There are other ways of doing it. For example, there are ways of plotting in a separate window. We don't want to do that for today. For today, let's keep things simple and let's make all the plots on this page. And for that, I will just run one more command called matplotlib inline, and it starts with a %sign. This is a class of commands. In Jupyter, there are commands which starts this %sign, and these commands are called major commands. We are not going to go into details of what these commands do. I'll just say for the moment that this command, if you write this command, and if you run it, it will force all the plots which you are going to make later to appear on this page. Okay, so let's do that. I made a mistake again, so it should be matplotlib inline. All right, so we are now ready to make plots. So let's make a simple plot, very simple plot. So the most common command for making a plot in Matplotlib is a plot. Okay, this function plot, is a very powerful function that makes a plot, and that function is inside Matplotlib, right? Because it is inside Matplotlib, I have to call it in a specific way, right? Because I imported Matplotlib through this abbreviation PLT. So whenever I want to call function from Matplotlib, I have to say plt.matplotlib. So Python knows that this function plot comes from Matplotlib. All right. So now I'm going to make a plot. The simplest way we can make a plot, we can define two lists. One list contains values of x-axis, and another list contains of values of y-axis. So let's make two axes. So this is the first one, will be our x-axis. Let's say that we have only 4 points, 1, 2, 3, 4. And let's say our y-axis is a 1, 4, 9, 12. Okay. Inside plot now we have 4 lists. Each of them have 4 points. These are x and y components accordingly. All right, let me try to run it. Okay, it's better to do it through this command show. Okay, here I have it. Okay. So it's 2 lines of code and I have a plot. I can also save this plot. Okay, I can also save this plot in a file. For that, I just say save fig and name of the file. Let's say I want to save it in a file called plot.pdf. Okay, so let me run it. So it should be saved. Let's check if it is saved. So let me go to my file system. These are my files. If I see what are the files, I see this new file called plot.pdf. Let's see what is inside that file. Okay, let me open it with a separate program. And if I open it, I have that plot inside. Okay, so I can not only show it here, but I can also save it here. All right. Okay, so this is a very, very basic plot you can make. As you see, to make a basic plot, you just need these two lines, okay? I just use these two lines to make this very basic plot. So now, let's complicate things step by step. Let's make more and more sophisticated plots, okay? So one thing to do is, let's define bigger arrays. We had an array of only 4 points, okay? Let's define bigger arrays now. And for that, of course, I have to import Matplotlib, not Matplotlib, NumPy, because arrays come from NumPy, right? So I'm going to import NumPy. I'm going to import NumPy, the abbreviation NP. So NumPy is imported. So if I want to define now bigger array. So in the last few lectures, we learned how to define arrays, how to declare arrays, right? And we used a function called zeros, okay? So first we created an array which consists of only zeros of a given shape and of a given type. There are many other ways of doing that. And another way which I'm going to use is through a function called arange. There is a function in NumPy called arange. It comes from NumPy, so let me put NP at the beginning. What it does is the following. So in arange, I give 3 arguments. That's a first element of the array. This is where array ends. It's the last element. Last element should approach to this second value. And the step. Let's say I want an array which ranges from 0 to 20 with a step of 0.1. Okay? So this creates that array. So let's see exactly how it looks like. So this is how it looks like. It's a little bit big. So as a test, just I will use, let's say, 1 only. And as you can see, there are, this creates an array. This last element is not included. It's not included here. That's the convention. That's how it works. So it ranges from 0 to 19. First is included, the last is not included. If you want to include the last 20, of course, you can say something like 20.1. In that case, 20 will also be included. You take a number which is a little bit of larger. All right, so let me redefine it again. So I want an array which ranges from 0 to 1 with a step of 0.1. Okay, I defined it. Okay, now this is my, let's say this is my x-axis. I want to define my y-axis also. And let my y-axis be some kind of function of the x-axis, which is a reasonable requirement, right? So let's say it's a cosine of x. Cosine of x. Okay? Here I'm using NumPy cosine, not the cosine function which comes from math library. I'm using the cosine function which comes from NumPy library. Why is that? It is because math functions like cosine, which comes from NumPy library, they can work with arrays. They are optimized for working with arrays, whereas the one which comes from math package, they do not know how to work with arrays. That's why we have to use cosine function which is coming from NumPy, because this x, this is array, right? All right, so let's plot this one. I say plt plot, I say x and y, plt show. All right, let me see. And here I have it. Okay, so very easy. Just few lines of code and I have a plot. Okay, let's make it, so very often you have to plot more than one function inside the same plot, right? More than one function, very often. So let's consider that case. Let's define another function, another array, y array, and let's try to plot that together with this function, okay? That's also very simple. So let's just define another array. Let it be exponentially damping sinusoid, okay? This is a sinusoid which doesn't damp, which continues oscillating. And I want another function which exponentially damps. I can just say I can introduce exponential term like this. Again, I use exponent, which comes from NumPy, because I'm using an array here. And I'm going to multiply to this cosine x, okay? The same cosine x, but multiplied by exponent. All right? So I have these two arrays. So I want to plot both of them. I introduced array. Let me run this. If I run this one, nothing changes. Why nothing changes?
Because we are not printing.
We didn't ask it to plot it, exactly. So in order to do that, I have to ask to plot this y1. So I just add one more line, I say y1. So let's try to plot, and here we have it. So this now plots two functions. This is original y, this is y1, okay? So it automatically chooses different colors so that we can differentiate it. Now, suppose we want to put some legend here. We want to tell the reader what kind of plot it is, okay? We can do that very easily too. We just say label equal to, let's say, x-axis. No, okay, oscillation 1, and let's call the second plot, green line, oscillation 2. Okay, let's try to run it. Okay, it doesn't show anything because we didn't ask it to show it again. In order to show these legends, we just say plt legend. Now it should appear. As you can see, now it appears. It says that blue line is oscillation 1, and this is what we wanted to say. Here we wanted it to say oscillation 1, and green line is oscillation 2. All right, very good, very good. Next thing we want to do, we want to tell the reader what is y-axis and what is x-axis. That's also very easy to do, okay? I just say plt x label. That's how I tell what is x-axis. Let me just say obvious thing first. And the same thing for y-axis. I just say x-axis is called x-axis, and y-axis is called y-axis, okay? Let me try to run it. If I run it, this is what I get. So I have the axis name now. One really cool thing about Matplotlib is that Matplotlib is integrated with LaTeX. So I can write LaTeX equations, for example, instead of in these places where I print out text in plots, I can actually write LaTeX commands, equations in LaTeX language. So since y-axis is sine x, right? I can directly say sine x, for example. So I should say sine x here. So the way to write LaTeX equations is to introduce $2 signs, and whatever is inside these $2 signs will be interpreted as LaTeX command. Okay, so in LaTeX, in order to write sine x, you just say sine x. Okay, let me try to run, and here I have it. Let's make it bigger. That's also very easy. I will just say size is, let's say, 24. Now I have it bigger. The same thing I can do for x. I just say x-axis, size is 24. Here I have it. So you see, now we have more or less acceptable plot, right? So it's a more or less complete plot. We have two different lines. We have labels of the axis, labels of the lines in this plot, more or less acceptable. Okay, and we achieve that by just writing a few lines of code, just a few lines of code. I want to make it a little bit more sophisticated also. Let's say this line is too thin for me. Let's say I cannot see this line. I want to make it thicker. That's also very simple. Just one more option in plot. I just say line width is equal to, let's say, 3. I want to make both of them larger. Okay? If I do that, I get thicker lines. There are many other things I can do. Let's say I don't like this color green. Let's say I want it to be red. That's also very simple. I just say color is equal to R. R means red. Okay? There are many other colors you can make, but let's start with R. Now, let's say I don't want to have solid lines here. Let's say I want to have dashed lines. You can make dashed lines as well as many other types of lines, but I will show you how to make dashed lines. I just say, there is an option called line style, and I say line style is this, and I get this kind of plot. All right? Line style equal to this. Okay, so as you can see, I can make basic plots very easily, and you can make very sophisticated plots. There are a lot of options of this function plot. There are many other options. There are different color options, there are line sign options, and so on and so on. So I'm not going to go through all of them today. I am just showing you the basics. If you are interested to learn more about that, the easiest way to learn about, for example, other options, you just type Google Matplotlib plot, let's say line styles or colors, and you get all the lists. And all of that is available in matplotlib.org website, and they have really nice tutorials, and you can find all the information about these functions on that website. There are also many very nice tutorials on YouTube, and you can learn more. Okay, so today I'm just going through basic ways of making basic plots. All right, so I made this plot. So I want to make now slightly different plot. Let me remove this. I want to make slightly different plot. Let's say my y is a function which changes by orders of magnitude. This previous function in this range didn't change by order of magnitude, right? It was 1 between its 1 minus 1. So I want something which changes by orders of magnitude. So I take 10 to the power x, and I'm going to multiply it by the same cosine function. So I had a cosine function before. Okay, so this is cosine x. Let me take square of cosine x. So I have two functions here, multiplication of two functions. Cosine x squared, and this for first part, 10 to the power x. Okay, it's a function which changes by orders of magnitude. Let me try to print it.
What about x?
X, I defined it before, so it's still in the memory. So I defined x to range from, okay, let me redefine it x actually. X is equal to, let's say, NP, a range, 1 to 20, 0.1, all right? So here I'm printing my y. So it starts from around 2.9, and it all goes to all the way to 1.9, 10 to the 19. So it changes by almost by 19 orders of magnitude, okay? So how we can make this kind of plot? So let me naively make this plot the way I did previous plots, okay? So this command. Okay, let me use. So if I do that, if I naively plot that, this is what I get. I only see the last part of this plot. The last part of the plot where the magnitude of y is very large. And I cannot see what's happening in this region. Okay? There may be interesting things happening in this region, which I need to know or which I want to learn. So here I cannot see it. This is a linear plot, right? This is shown in linear scale. So if you want to see regions which has much smaller values, you of course use what kind of plots? Plots in logarithmic scale, right? And that's also very easy to achieve. You say PLT, y scale, you just say log. And this is what you get. So now we plot it in log scale. And it turns out, indeed, there is these structures, and maybe I'm interested in knowing these structures, whereas in this previous plot, I wouldn't be able to see it. You can do log scale not only for y-axis, you can also do for x-axis. You just say PLT x scale, the same thing, log. And now I get this plot. Both y and x's are in log scale. All right? Okay, very good. And I want to show you now one more thing. Very often in computational science, when you're doing computational work, your data is in some files. Okay? And for example, very often you want to plot that data. Okay? You want to take that data from a file and you plot it. So I'm going to use the data which I used for in my previous lecture. I had the data which contained two columns. One is the number of students, second one is the grades of students. Okay? I slightly modified it. I also added a text comment to that file. And this is how that file looks like. This is in a file called grades2.txt. And this is how that file looks like. Let me make it bigger. So this is how it looks like. So I have this first line, which is not data. It's just the explanatory text. And very often in many data files, beginning few lines doesn't need to be just one line, 2 or 3 files, or 10 lines, usually a description of what is inside that file. Okay? And then I have my data. This is student number 1, has a grade of 9.17 and so on. Student number 2 has a grade of 95. And all the way up to 100, student number 100 has a grade of this. Okay? So I want to be able to plot that. I want to be able to plot that. All right, how I can plot that? So in order to plot that, I have to read that file first, right? And as we learned yesterday, there are many ways of reading it, but we used one particularly easy way of reading that file, and through a function called load.txt. That function comes from NumPy, so I have to say now np load.txt. That reads a file, and my file is this here, Python class grades2.txt. Now, I have to add one more option here, because there is this first line there, which is text, which is not a data, which is text, right? So I have to tell this function load.txt to ignore that line. Okay? I can do that through this option called comments, that's equal to this. So if I write that, all the lines which starts with this sign, and here it starts with that sign, all the lines which starts with that sign will be ignored. It will not read. Okay? And so this is very simple. It reads this one. If I run, it runs. So what happens is that this load.txt reads that file, correctly identifies that there are 2 columns of data, and out of these 2 columns of data, it created an array, 2-dimensional array, and assigned it to A. Okay? So let's see if that is indeed the case. Let's print A. If I print, and I get these grades. Okay? All the grades are here now. I can operate with that. Now, previously, when I was making plots, I was plotting it x versus y versus x, right? So I had one array y and another array x. So let's get 2 arrays out of this 2-dimensional array. Okay, we can plot it directly, but to make it simpler, let's get 2 arrays out of it. Let's get 1 array out of this first column and another array out of this second column. That's very easy to do. I just say x equal to a colon 0. What does it do? As I explained in the last lecture, this command takes the first column, column 0 of array A, and assigns to x. Okay? So let me try to print x to see if that is indeed the case. Indeed, that is indeed the case. So x now is an array which starts from 1 to up to 0. Okay, let me introduce now y. Y is equal to a, and I'm taking now first column, the second column, sorry. Let me try to print it, and I get that. Okay, so now I introduce 2 arrays. I have 2 arrays, x and y. Each of them are one of those columns. Now I can plot one against another. I just say plt plot x and y, plt show. Let's try to see. And here I have it. So here I plotted the data. Okay. All right. So today we learned to make very, very basic plots, and we'll be making similar plots throughout the course in this class. Okay. Occasionally, we'll have to make more complicated plots, like 3-dimensional plots. Okay. I'm not going to go through those cases today, but we'll learn those things as we move forward. When we need them, we'll learn. If you're interested, though, you can go to a website called matplotlib.org, and you can look at, for example, this gallery. There is this huge gallery in matplotlib.org, matplotlib.org/gallery. There is a huge gallery of different plots which are made using Matplotlib. Okay, there are so many different options. As you can see, I will scroll down, and I will see all sorts of different plots. And all of them are, as I said, made in Matplotlib. For example, here we have some contour plots. For example, here I have 3-dimensional plots, 3-dimensional surface plots, scatter plots, and other things. Okay. So if you want to make some, let's say, particularly plot for, not for this class, but for other things, or maybe for this class also, what you can do, you can go to this gallery, look at this gallery, find a plot which is closest to what you want to plot, and you can download the code which does that. So here is the code. So you download the code, and if this is the plot you want to make, you can just modify the data and make that plot. If you want to make it slightly different, you can modify the code and get that kind of plot. This is where I would recommend to start. Or there are also, as I said, many tutorials on this site, on YouTube, and many other places. So if you want to learn deeper, you can go there. But today, we just learned the basics, how to make very, very basic plots. Okay, so this is where I stop today. Okay, thank you. All right, so time for questions.
Is there any code, for example, we plot the graph, we plot the plot, yes,
Mm-hmm.
and some code which will change the type of the plot.
Type of the plot? Well, so, okay, so you want to change the type of the plot. For example, so let's make it specific.
Or not graph, for the barcode.
For the barcode, yes. So for example, here, we can find bar plots, right? Bar plots. You want to make this, for example, here, this one, something like this one. So let's look at it. So here is, I click it, and this is the code for that. So for that, you use a command called hist. This is a histogram actually. It's not plot. We use the function plot. For this one, we use the function hist. Okay, another example. For example, this is contour plot, right? And for that, I use this histogram 2D. There are many different options. For example, let's see what is this one. I don't even know how to make it. But I can quickly go and see how this guy is made, and I can modify it. This is more complicated, as you see. It requires more code. But you see, you can write very high level, very sophisticated plot. So suppose you need something like this, or something very similar to this one. So you can go here, look at the code, understand how it works, and then you can modify the code the way you want. Okay? So this is how I would do it. All right, any other questions? All right, thank you very much. Thank you for coming.